Here we have a balloon filled with helium gas at 23 degrees Celsius. The balloon expands until it is equal to atmospheric pressure, which is 755 torr. So here we have our balloon, and it says it rises to an altitude of 6,000 feet, and as you can guess, it's going to expand. Okay? The altitude really doesn't matter, it's just that we're interested in that it expanded. And here the pressure is 550 torr and temperature is 5 degrees Celsius. So here we have a pressure, I'll call that P final, that's 550 torr. And our temperature final is 278 Kelvin, 273 plus 5 degrees. Our initial pressure was 755 torr, and our initial temperature was 273 plus 23, so that's going to be 296 Kelvin. All right, so the question is calculate the percent increase in volume. So percent increase, well, that's going to be the volume final minus the volume initial. That's going to give us the volume increase. And if we want to get a percent, we're just going to take that over the initial volume times 100. So the change over what we started with times 100, that's going to give us the percent increase. So that's what we want to figure out, are these volumes. Well, we're not going to be able to solve for V directly, but we can solve for relative what V is. Here's what I mean by that. An initial volume, knowing that we'll write up here PV equals nRT, right? So our initial volume is going to be nR T initial over our pressure initial, right? That's solving PV equals nRT for initial volume. Well, our final volume is going to equal nRT. This is going to be final temperature, final moles, over pressure final. We'll put initial here. Well, if you start thinking about it, the moles are going to be the same. But what I would like to do, because the moles initial equals the moles final. Also, we know that R equals R. So we're going to plug this, substitute this in for the final, and we're going to substitute this in for the initial. And we're going to simplify the whole thing. Okay, so, and by the way, this will be absolute value. So let's go ahead and do that. Let's plug in these values for volume. And let's make some space here. Okay, so my percent increase, it's going to look complicated, but it really won't be after a minute. So I'm going to take the final times R times temperature final over pressure final, and I'm going to subtract the initial, so that's going to be Ni R Ti over pressure initial. Okay, and then we're going to have our initial on the bottom, Ni R Ti Pi. Now we're going to simplify this because R can be canceled out just knowing basic algebra. And we know that the moles are the same, so we get rid of those. And now this whole thing kind of simplifies. We can simplify this out to TF over PF minus TI over PI. and that is going to be all over Ti over Pi, and this of course is times 100. Okay, so now all we have to do is plug in our values. So let's do that. Our final temperature is 278 K over our final pressure, which is 550 torr. We're going to subtract from that our 296 Kelvin over 755 torr. And that's going to be over 296 Kelvin over 755 torr. And that again is times 100. So I ran out of room here. Sorry for scrunching that in. Okay? This should also be times 100 up here. Okay? You're going to do that math on your own, but when you finally get it, it comes out to 28.8%. And that's an increase in volume of 28%, 28.8%.